In the case of petrol engine, we said because combustion duration is smaller, your rate of pressure rise, your temperatures which are reaching in the petrol engine, those are higher as compared to diesel engines. If temperatures are higher, nitrogen and oxygen is reacting and forming oxides of nitrogen. That's a serious problem. One video I'll be showing about how this exhaust system is working, how the silencer, how your catalytic converter is working. Exhaust system of engine in what way it is working, that I'll be explaining. Engine exhaust system. Hot gases which are coming out, they are passing through catalytic converter and silencer. What converter is doing? The exhaust production coming out is having oxides of nitrogen and hydrocarbons. So it is having first of all oxides of nitrogen in taste, that is very much using for the PTM or ceramics are using. So it is doing first of all oxides of nitrogen are getting converted into nitrogen oxide. Oxygen is becoming free. Next is the CO and hydrocarbon which are there, they are getting oxygen. Temperatures are significantly higher. CO is reacting with oxygen, it will be converted into CO2. Unburned hydrocarbons again goes to dissociation of oxides of nitrogen into nitrogen oxide. Insufficient oxygen is there, that unburned hydrocarbons oxygen is combining with forming H2O plus CO2. So now CO2, H2O, vapors, nitrogen, those are the pollutants. So the purpose of the catalytic converter is in fact to reduce the harmful gases from harmful to low harmful gases. It is converted. These type of catalytic converters are able to use to two occasions. We are unable to use when we are using petrol. For that is in two-stroke engine, we are mixing lubricating oil. Lubricating oil even combustion chamber it is reaching, it is taking part in combustion, partially but lubricating oil comes out to silencer. If you are using a converter, those lubricating particles will make air on the catalyst and effectiveness of catalytic converter will go down. So in two-stroke engine we are unable to use, even if you are using lighted petrol, that is not taking part in combustion. The unwanted particles form of video, they will be coming outside particles. So particles will be coming into the catalytic converter, they will layer on the surface of the catalyst and it will become ineffective. So if you are using catalytic converter, we like to have unleaded petrol. Even sulfur content should be low. So if sulfur contents are there, those contents will be making layer on the catalyst. It will put out. And third one, in two-stroke engine, a lot of lubricating oil is mixed with the petrol and partial lubricating oil is coming out. It will somewhere on the catalyst and will go. After that one, we are having a muffler. The purpose of muffler is dissolve. Mainly it is due to friction. The speed is increasing, the pressure is getting converted into heat, and the waves are moving like this, they will be coming back, other coming like this, and they each other. So the energy level is due to friction or due to this of this wave is reducing its energy. So purpose of balance, purpose of catalytic converter is converting harmful gases into low harmful gases, and what is the oxides of nitrogen or particulate matters level. If you see, somewhere in 1970. These norms, the equation of these norms which are coming, EPA, Environmental Protection Agency, is there at global level. They have framed the norms in somewhere 1970. It has been started. In our country, we have started in 2001, 2002. And when the problem became very serious, Supreme Court came into picture, particularly the example of Delhi I was giving near ITO circle, the example yesterday I have given. So Supreme Court said to the manufacturers, these norms are not for us. It is not for the users. The vehicle, if I am having a car, these norms are not meant for me. The norms are for the manufacturer. When car is coming out after manufacturing into the market, first of all, the norms which are there, and norms are on mass basis. The norms which you are having, it is on mass basis. Meaning of mass basis is, suppose one car is moving for 1 kilometer. In terms of mass, how many grams of CO should come out when it is moving through 1 kilometer? How many grams of oxides of nitrogen should come out? How many grams of particulate matter should come out? How many grams of hydrocarbon should come out? It is on mass basis. And when we have manufactured the engine, testing of the engine is being done on chassis dynamometer. Just it is being assumed that it is moving on the road. Actual situations which it will be facing when it will be moving road, those type of conditions are being created on the dynamometer. In different loads, different gears, it is being operated, and with respect to time, the exhaust which is coming out through the silencer, it is collected, and then finally its constraints are measured, that in this particular time, if at this particular speed vehicle would have moved, then how many kilometers it has gone, and during that time how many grams of the COHC should have come out. But who will be deciding these norms? Suppose vehicle is moving for 1 kilometer, how many grams of CO should come out? Who will decide? इसको डिसाइड कौन करे? सुप्रीम कोर्ट ने तो कह दिया कि आप जो है नॉर्म्स बनाइए इसके, but norms बनाने के लिए some exercise has to be. In your examination system, we are saying first division someone will be having if 60% marks are there, 75% marks honors degree will be having, pass marks 36% marks. But who have decided? How it has been decided? How we have reached this conclusion? So it may be by experience, long experience. If 60% marks means student is better than the marks which we are having. If it is 75, it is extra only. If it is 36, just he can move into the class. If it is less than that one, he'll have to give more opportunities so that it can improve the base. But it has come through experience. Now, as far as this emission part, if I am saying, and in terms of grams, if you are deciding, who will decide? Easiest approach is, suppose in class you are giving some problem, tutorial problem you are giving to the students. One student is very good. Easiest approach for remaining students are, when he is doing that exercise, when he is solving that question, you copy. For remaining student, it is very easy approach. Once someone has done, you copy. That's the easiest approach. When Supreme Court came into picture in our country, the intervention from the Supreme Court to industry people that you make some norms. So easiest approach was, whatever others were having, we are copying. In 2002, we are copying, and copying those norms which European countries had in 1992. आप 10 साल बाद कोई नॉर्म्स कॉपी कर रहे हैं, और वो जो यूरोपियन कंट्रीज where population is very low, if population is less, then your solid waste, everything is low. In our country, the biggest problem is we are 1.21 billion, and the solid waste which is being generated, it is more than 40 million tons in a year, and in 2020 it will become 200 million tons. And that solid waste is lying in open areas, in the open landfill. It is creating lot of gases, methane, everything is generated, and it is polluting the atmosphere. And we are comparing with these European countries and what they have framed 10 years back. And that name we have given Euro 1, EURO1. We have copied from them, and name we have given Euro 1. When Euro 1 was being implemented, not a single manufacturing industry have been stopped from the production, because those norms were not so stringent. 10 साल पहले बनाए थे तो इतने norms थे ही नहीं. आपको तो strong norms चाहिए थे जिससे really technology change हो, fuel change हो, जिससे pollution आपका जो है कम हो. उसका नाम हमने भारत 1 भी दे दिया, या भारत 2 बाद में दे दिया. भारत 2 which came Euro 2, those were the norms which European countries have framed in 1996. फिर उन्होंने कोई जो है 2000 के आसपास बना. इस तरह से हम उनको जो है कॉपी करते गए. When we are measuring those pollutants on chassis dynamometer, when we are operating the vehicle, there is a cycle in fact. There is a cycle for 15 minutes. And meaning of cycle is, that 15 minutes you operate your vehicle, roughly speeds of the vehicle should be around 60 kilometers per hour. Means it is hypothetical. On chassis dynamometer it is there, and conditions which are being applied, forces which are being applied on this one, so that these are those forces which actually vehicle would have been moved at this speed of 60 kilometers per hour. Same forces are being applied. So quantity of fuel which will be injected, that will be same. The pollution formation will be same. What our Indian people have done, testing of the vehicle they have done for 15 minutes, but in place of 60 kilometers per hour, the condition which they applied for 40 kilometers per hour. जब 40 किलोमीटर की स्पीड पे चल रहा है व्हीकल, तो आपका फ्यूल कंजप्शन भी कम है, उसका फ्यूल की सप्लाई भी कम है, आपके पोल्यूटेंट फॉर्मेशन भी कम है. एक्चुअली इफ सेम स्टैंडर्ड्स वी हैव टेकन, इवन सेम साइकिल वुड हैव बीन टेकन फ्रॉम देयर. तो साइकिल तो हमने अपनी बना ली जो अपने को ठीक लग रही थी इंडस्ट्री वालों ने, और नॉर्म्स वो ले लिए जो उन्होंने 10 साल पहले किए हुए थे. एंड the mixing which you have done in such a way that all the industry people could survive, और एक के भी कोई परेशानी जो है नहीं आई, सारे के सारे बच गए. इवन मारुति का प्रोडक्शन एक दिन के लिए नहीं रुका. When the same thing has been reported to Supreme Court कि इन्होंने साहब चालाकी कर ली इंडस्ट्री वालों ने, तो आपने जो कहा उसको तो फॉलो ही नहीं किया, कुछ इन्होंने अलग तरह से अपना ही सिस्टम बना लिया. Again Supreme Court said that you take that cycle also, not only those norms, you cycle take. And when the cycle was implemented, then the production of Maruti has been stopped for 1 month. बंद हो गई थी इंडस्ट्री जो वो नॉर्म्स लागू करने के लिए. अपन जो पेट्रोल पंप पे मेजर करवाते हैं, जो मेजरमेंट करते हैं ना पेट्रोल पंप पे, दिस पोल्यूशन सर्टिफिकेट कुछ लेते हैं अपन पेट्रोल पंप वालों से लेते हैं, इट इज नॉट ऑन मास बेसिस, इट इज ऑन वॉल्यूम बेसिस. इट इज कमिंग आइदर इट इज इन परसेंटेज CO, percent hydrocarbon percentage, or ppm, parts per million. If it is level is very low, it is ppm, otherwise it is on the basis of percentage. And how we are doing the testing? Diesel engine we are testing only for smoke. For diesel engine, the certificate which we are taking, it is not CO or oxides of nitrogen, hydrocarbon, and even we are saying it is not important also. In the case of diesel engine, CO is not important because excessive oxygen always is available. Smoke is important, and when smoke is important, smoke is particularly important when engine is loaded. If it is idling, just we are standing engine in start condition, that time air fuel ratio is around 80. 80 means mostly it is air. Quantity of fuel which has been injected, it is very small. It means CO formation is smoke formation is very low, and that time we are testing on the petrol pump. अपने तो ट्रक को कह दिया कि आप स्टार्ट कर लो, स्टार्ट करके वो साइलेंसर के जो है पीछे लगाता है उसका सैंपल लेने के लिए. There is no use of that one. Because at the time of idling, first of all, idling time is very small, and second idling time, the smoke formation is very low. So there is no use of that measurement. Then we are measuring CO and SC in petrol engine, and that we are measuring at the time of idling. One question someone was asking at the time of brake, that when inlet valve be opened, exhaust valve already it has been opened, there is a overlapping, some of the burnt products may go into the intake manifold. Yes, it is going, and particularly it is going when it is idling. At the time of idling, your throttle valve is more or less in closed position. Engine is trying to suck the fuel and air mixture into the cylinder, but at the same rate it is not coming because throttle is in closed position. So lot of vacuum is created in the intake manifold. Lot of vacuum is there, your intake valve you opened, exhaust was going on. So due to that pressure difference inside the cylinder, pressure is more than atmospheric. In the intake manifold, lot of vacuum is there. So many of the burnt products, they are entering into the intake manifold, particularly at the time of idling. And at the time of idling, always we are supplying rich mixture. It is not 15. In the case of petrol engine, it is 7, 8 like that one. That time very rich mixture we are supplying. If rich mixture is there, then chances of formation of CO will be very high. Chance of formation of HC will be very high. And that time we are measuring. HC, CO we are measuring when it is in idling. There is no use again for the petrol engine because वो जो measure कर रहे हैं वो excessive है. डीजल इंजन में जो मेजर कर रहे हैं वो है ही नहीं. उस टाइम अपन मेजर करें, both the conditions are not was the actual condition. Second one, the person who is handling that equipment, COSC analyzer, it's a standard method when we are measuring the exhaust emissions, when we are doing research. Every 24 hours, after every 24 hours, it has to be calibrated. Calibration of that one. Standard gases are there for the purpose of calibration. Even the person who is handling, who is illiterate, he doesn't know in what way this equipment has to be operated. Forget about this calibration, everything. So measurement which you are doing at the petrol pump for taking this certificate, there is no meaning of that one. And in the industries, what you have done, that was also not meaning. अब जो चलते गए स्टिंजेंट नॉर्म्स होते गए देखो आप किस तरह से अपन जो है आए हैं। ये जो था ये ग्राम्स पर किलोवाट आवर, ग्राम्स पर किलोवाट आवर जो है 20 ग्राम्स पर किलोवाट आवर अगर मान लो 1970 में था, तो अब करीब 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 जाके नॉर्म्स जो है ये यूनाइटेड स्टेट्स के नॉर्म्स करीब करीब जीरो पे पहुंच गए हैं। ये नीचे वाला देखिए आप जो है जहां चले गए ना अपन 2000 के आसपास जो जा रहे हैं अपन 2010 में 2000, ये लेवल कितना आ गया, करीब करीब जीरो पे आ गया है। सो नॉर्म्स ऑफ दिस ऑक्साइड्स ऑफ नाइट्रोजन इवन पार्टिकुलेट मैटर, जो पार्टिकुलेट मैटर्स वगैरह का लेवल जो है ना वो करीब करीब अपन जीरो पे पहुंच गए हैं। That's why I'm saying these people are using 50% of the petroleum products of the world and still they are not suffering from this very high pollution, because their technology of the engines which they have changed, the injection system they have changed, and the quality of fuel which they are using, that is so good that this problem is not coming, serious problem is not there. Serious problem is in our case where 90% vehicles which are using are of old technology. The fuel which you are using for the purpose of, for the sake of the people who are really using, they are not competitive enough or rich enough to pay according to the rates which are at the global level. So in our case, both technology and fuel, both are lagging. So I'm discussing here your fuel system, your fuel technology, your off treatment technology, your control technologies, everything just like catalytic converter, these are the control technologies. आफ्टर ट्रीटमेंट इट इज पार्टिकुलेट मैटर्स को जला दिया जाता है। अभी डॉक्टर खत्री आएंगे वो अपने को बताएंगे कल परसों जो है जो पार्टिकुलेट मैटर्स निकल रहे हैं ना सल्फर और ये बिफोर एंटरिंग इनटू द एटमॉस्फेयर इनको जलाया जाता है, जला दिया जाता है या ट्रैप कर लिया जाता है। इफ यू आर ट्रैपिंग देन आपका एग्जॉस्ट के अंदर काफी बैक प्रेशर क्रिएट हो जाता है। इफ यू आर पुटिंग एनी ऑब्स्ट्रक्शन इन द साइलेंसर, द गैसेस आर ट्राइंग टू गो आउट, बट if some obstruction is there in terms of filter, piston is trying to push those one products out, but if you put the obstruction for filtering purposes, it will be creating lot of back pressure. So आपके एग्जॉस्ट की जो लाइन जो मैं बता रहा था नीचे वाली जो लाइन ऊपर वाली लाइन थी ये और ऊपर उठ जाएगी, योर नेगेटिव वर्क और पंपिंग एरिया विल इंक्रीज, वर्क बढ़ जाएगा। सो इवन आपने कैटलिटिक कन्वर्टर लगाया वो भी लाइन को ऊपर लेके जा रहा है, आपका मफलर भी जो लाइन को ऊपर लेके जा रहा है, एंड ऑल द ट्रीटमेंट डिवाइसेस व्हिच यू आर पुटिंग इट इज क्रिएटिंग लॉट ऑफ बैक प्रेशर एंड इंजन एफिशिएंसी इज गोइंग डाउन। सो कुछ जलाने की बात करेंगे, वो काफी टेक्नोलॉजीज ये डेवलप कर रहे हैं, खुद डेवलप कर रहे हैं, डॉक्टर दरिया सिंह जो आए हैं ये डेवलप कर रहे हैं, वो अपने को इन चीजों को बताएंगे कि पार्टिकुलेट मैटर्स को कैसे नष्ट कर दें जिससे आपका बैक प्रेशर पे भी कोई फर्क नहीं पड़े, इंजन की एफिशिएंसी पे कोई फर्क नहीं पड़े, एंड एमिशंस कैन बी गो डाउन। सो इट इज टर्म्ड एज आफ्टर ट्रीटमेंट। when it is coming out from the engine, then what type of treatments are being done, that is after treatment. ये स्टैंडर्ड नॉर्म्स 91 से चल के जो 91 बार स्टेज 4 तक के नॉर्म्स है जो सीओ का, और एचसी को अपन अकेला नहीं मानते, एचसी प्लस नोक्स के इकट्ठे मिला के नॉर्म्स है, हाइड्रोकार्बन्स और नोक्स दोनों मिला के जो है, एंड इट इज सेड सेपरेटली दिस एचसी इज नॉट हार्मफुल, separately it is oxides of nitrogen are there, it is not harmful. If both are there, HC plus NOx both are there and sun is present, then photochemical smokes, everything which is being formulated, then it is harmful. So the norms which we are having according to this Barth stage norm, more or less we are reaching towards the negligible side if stringently it is being followed. पर आप फॉलो किस पे करोगे? जो व्हीकल निकल के आए वो तो पुराने हैं अपने पास, ये नॉर्म्स तो उन पे हैं जो नए व्हीकल निकल रहे हैं उनके ऊपर लागू हुए हैं। पुराना अपने 20 साल पहले खरीदा है, 15 साल पहले, उस पे तो लागू ही नहीं हुए ना ये अपने। एंड मेजॉरिटी ऑफ द व्हीकल्स व्हिच आर हैविंग इट इज ऑफ ओल्डर टेक्नोलॉजी, अपने बाद वाले है ही नहीं बहुत ज्यादा व्हीकल्स जो। दैट्स व्हाई इन इंडिया दिस टाइप ऑफ प्रॉब्लम इज। सो एवरी दिस स्टेज व्हिच इज वेरिंग विद स्टेज these norms are becoming more and more stringent, कम से कम होते जा रहे हैं, एंड यूनिट इज ग्राम्स पर किलोवाट आवर और ग्राम्स पर किलोमीटर लाइक दैट। स्टेशनरी इंजन है तो उसके अंदर किलोवाट आवर, जनरेटर आपके जो है चाहे 1000 किलोवाट का जनरेटर, इट इज स्टेशनरी इंजन, सो इन दैट केस इट विल बी ग्राम्स पर किलोवाट आवर। इफ इट इज मूविंग, इफ इट इज ए कार, इट इज ए बस, इट विल बी ग्राम्स पर किलोमीटर। ये पैसेंजर कार्स के लिए है। इसी तरह से हैवी डीजल व्हीकल के लिए भी अलग बने हुए हैं सारे नॉर्म्स जो है उनके लिए। पार्टिकुलेट मैटर भी डीजल के लिए, पार्टिकुलेट मैटर इज बिकमिंग इंपोर्टेंट इन डीजल, इट इज पार्टिकुलेट मैटर। आपका पेट्रोल वाला देख रहे थे ना, पेट्रोल में पार्टिकुलेट मैटर नहीं है, इन डीजल पार्टिकुलेट मैटर मेनली ड्यू टू सल्फर इट इज देयर। तो हियर ओनली दिस वन CO HC प्लस NOx, यहाँ पे ये काफी कम है आपके, ये वाला पार्ट काफी कम है, HC वगैरह बहुत कम है, CO काफी कम है, ओनली दिस पार्टिकुलेट मैटर्स आर इंपोर्टेंट। And from where these exhaust emissions are? from these emissions which we are having from the vehicle. One is your fuel tank. It is not getting controlled. Fuel tank we are unable to control. Some of the technologies these days are coming, some PCV controls are there. So even this vaporization, even fuel which has been vaporized from the fuel tank, that is again being sent to carburetor or to injector. So vapors are not allowed to go into the atmosphere. Before going out into the atmosphere, they sent for the purpose of combustion. So those type of arrangement in the fuel tank, in the carburetor, in the float chamber of the carburetor, all they are vented to atmosphere, and silencer HC plus CO plus NOx coming out. So from fuel tank, from the carburetor, and then we were saying blow by also. Blow by means through pistons, they are going toward the crankcase side, and then so the modern vehicles which are coming, even from the crankcase, the blow by which has gone, those blow bys are being sent to carburetor again. So it is not allowed to go out into the atmosphere. So everywhere it is being controlled, and silencer HC plus CO plus NOx is being controlled from that side. And the norms which we are having, the Euro norms which we are having, it is for this one, HC plus CO plus NOx, which is coming out from the silencer. And in the case of diesel engine, important is particulate matter. Those are more important. Those are not severe. The color which is visible, it is smoke. And the particles which are there, which is having color black, those are particulate matters. Volumetric efficiency already we have discussed. Wall timing आपको बातचीत की अपने wall timing के बारे में. I think more or less wall timing is clear. There is no confusion. This according to Stoke I've indicated here wall timing. आपकी closing जो exhaust valve की है, if you are comparing petrol engine and diesel engine, in which case will be closing late? This one is closing. This one is closing of the inlet valve. Yes. If we are having a diesel engine, if you are having a petrol engine, in which case will be closing late inlet valve after BDC? Diesel. Yes. Petrol engines are being operated at a higher speed. If speeds are higher, fresh mixture which is entering from the inlet valve, its velocity will be more, its kinetic energy will be more, its ramming effect will be more. So in which case better advantage of ramming effect we can take? पेट्रोल इंजन और डीजल इंजन, जो मिक्सर एंटर हो रहा है, इंजन की स्पीड ज्यादा है, जिस स्पीड इंजन की स्पीड ज्यादा है उसमें ज्यादा स्पीड से मिक्सर एंटर होता है, उसके पास एनर्जी ज्यादा है. सो वाल्व क्लोज करते टाइम अपन एनर्जी का एडवांटेज लेना चाहते हैं कि जो आ रहा है वो आता रहे, अंदर आता रहे, एंड तब क्लोजिंग करनी चाहिए जब सारी एनर्जी उसकी काम में आ गई हो. सो इन विच केस एनर्जी इज मोर, पेट्रोल इंजन और डीजल इंजन? पेट्रोल इंजन, बिकॉज इट इज ऑपरेटेड एट हाई स्पीड. तो क्लोजिंग लेट किसकी करेंगे अपन इनलेट वाल्व? पेट्रोल की, क्योंकि उनके पास ज्यादा एनर्जी है फ्रेश मिक्सर के पास, और वो ज्यादा टाइम तक अपन यूज लेना चाहते हैं, वो आता ही रहेगा अंदर की तरफ, एंड लेट क्लोजिंग विल बी डूइंग. एंड योर कंप्रेशन रेशियो ऑल्सो, जब तक क्लोज नहीं करोगे तब तक एटमॉस्फेरिक प्रेशर रहता है सिलेंडर के अंदर. एक्चुअली योर कंप्रेशन रेशियो हैज टू बी मेजर्ड फ्रॉम when your inlet valve has been closed, then only compression will start. So it is effective, it is sometimes effective compression ratio. If we are calculating compression ratio from the volume when your inlet valve has been closed, and that volume if you are adding as a swept volume plus clearance volume, that is constant, divided by VC. So your effective compression ratio is lower than the theoretically compression ratio which you are calculating. This is diagram. This was overlapping which I was showing. Overlapping of both the valves. Then both inlet and exhaust valves are in open position. It is overlapping. Sometimes we are saying scavenging. Scavenging means with the help of press mixture, we are saying one products are being mixed, but we are not agreed with this one. We are not agreed with this one because inlet pressure is lower as compared to the exhaust pressure. Only due to this energy it is continuously going out, and that will be going on. Turbocharging and supercharging, there are two terms in fact, and particularly in diesel engines, for increasing the power output, more air will be. If the pressure of air is much more, if pressure is more, density of air will be more. In same volume, if density is more amount of air we can supply. The difference between turbocharger and supercharger is, supercharger we are using with the help of the output of the crankshaft, mechanical linkages between the compressor and crankshaft there is a mechanical linkages, and compressor we are using operating with the help of the energy of the crankshaft. But in the case of turbocharger, energy of the exhaust gases, and particularly energy it is having high because we are opening exhaust valve before BDC, where pressure of the burnt product may be 4 bar, 5 bar. That time we are opening, and that high pressure energy which is going out through the silencer before entering into the atmosphere, we want to utilize that one. And small turbine we are using, and RPM of the turbine is around 1 lakh RPM. Very small turbine, 1 lakh RPM of the turbine which is being operated, and that is giving its output to a compressor, small compressor that is compressing the air, and that high pressure air we are supplying to the engine. Sometimes we are saying twin turbocharger, means that there are two turbochargers. If engine is a 6-cylinder engine, we can't connect all the exhausts in a common in a common silencer. We can't connect. Silencers are two, or after certain distance we are joining them all together. एक साथ सारे वाल्व एग्जॉस्ट वाल्व को अपन कनेक्ट नहीं करते अगर 6 सिलेंडर है तो. इसका क्या रीजन हो सकता है आपका? When we are having, first of all, suppose 4 cylinders we are having, your opening of inlet valve, it is more than 180 degree. Your suction stroke is for 180 degree. Before TDC, some 10 degree before we are opening, some 30 degree after BDC we are closing. So what is the total duration of suction? 220 degree. Yes. And if 4 cylinders are there, 220 plus 220 plus 220 plus 220, 880. But crankshaft rotation is 720 in a cycle. So इसका मतलब कुछ पीरियड ऐसा हो गया जिसमें एक सिलेंडर में अगर नंबर 1 में आपका सक्शन है तो उसके 4 में भी सक्शन हो. Yes, there is a overlapping. Similarly for the exhaust also. Similarly there is a exhaust also. If in 2 exhaust is there, there are chances in 4 exhaust is also there. So आपस में एक दूसरे exhaust एक दूसरे को डिस्टर्ब कर सकते हैं. तो exhaust की लाइन भी इस तरह से जोड़ते हैं अपन कि टाइमिंग्स इस तरह से होती है कि 1 3 5 3 we are connecting, then 2 3 4 we are connecting. जब उनके आपस में मैचिंग हो ही नहीं, एक दूसरे को डिस्टर्ब भी नहीं करें, सो साइलेंसर भी अपन इस तरह से प्लान करते हैं उनकी कि एक दूसरे का एग्जॉस्ट जो है जब ओवरलैपिंग पीरियड हो तो डिस्टर्ब नहीं करें. सो ट्विन turbocharger means when 2 exhaust separate exhaust is there, in a separate exhaust separate turbochargers we are providing, and that energy is being utilized. Can we use in a single cylinder this turbocharger? This turbocharger can be used in a single cylinder engine. Can we use in a single cylinder engine in 4 strokes? Only once will be getting exhaust. So the exhaust which is being received by this turbocharger, it is intermittent, it is not continuous. If you want to operate continuously this one, continuously exhaust should come over the surface of this one. If it is a single cylinder, it is not continuous, it won't be operated. So minimum how many cylinders has to be? 3 से तो ज़्यादा ही हो आपके. Then only continuously this exhaust will be coming over the surface of this one, and we can operate this one. Even when it is compressing this air, when it is being compressed, the temperature of air becomes quite high. Due to compression, temperature of air becomes quite high. If temperature increases, what will the effect on density? Yes. Density we are saying P upon RT will reduce. Pressure will increase, but temperature has gone up, your density has gone down. So in the same volume, the amount of air which will be filled, that air will go down. If temperature is increasing, it will go down. So what will have to do before supplying to the cylinder? Cooling of intercooler. So the even compression is in 2 stages. First stage, it is compressing the air, then cooling of this one with the help of atmospheric air, and then in second stage it is being compressed, and then it is being supplied. So आपने गाड़ियों पे intercooler भी लिखा हुआ होता देखते हैं. Intercooler is basically intercooling the air between the stages of the turbocharger. Yes, stages of the charger. So more or less, even in the diesel case also, the temperature of air when we are supplying to the cylinder, when it is entering into the cylinder, more or less its temperature has to be atmospheric. Otherwise, density will go down. High temperature air is advantageous as far as your delay period is concerned. That way it is advantageous. Delay period it will be reducing high temperature, but its density will go down. Engine output will go down. Volumetric efficiency will go down. If high temperatures are there, volumetric efficiency will be less. This arrangement, turbocharger arrangement which I was showing, turbocharger exhaust जा रहा है, इसे compress करके intercooler cooling की अपने, and even radiator air is being utilized for the purpose of cooling. and then air is supplied to the cylinders. कुछ टू स्ट्रोक इंजन का अरेंजमेंट भी दिख रहा है आप लोगों को? Yes. In the case of two-stroke engine, your whole cycle is completed in two strokes. Two strokes are completed, crankshaft is rotating by one revolution. In the case of four-stroke engine, after completion of four-stroke, two revolutions were there. In this case, there are ports. In fact, there is no valve, and due to the availability of these ports, the problem which is coming from one side, fresh mixture is entering. Another side, your exhaust is going on. Chances of fresh mixture to go out into the atmosphere, and always it happens, lot of fresh mixture is going out. That's why efficiency of these two-stroke engines are very low, because most of the fresh mixture it is going out, and particularly when load on the engine is higher, आपकी throttle opening ज़्यादा खुली हुई है, then in crankcase more mixture will be entering. Yes, pressurization of that mixture with the help of piston will be more. High pressure fresh mixture will be entering into the combustion chamber, and it will be forcing the burnt products out, and same time high pressure fresh mixture will be also going out. So when load is higher, the chances of this short circuiting of this fresh mixture, it will be much more when we are operating at a higher load. ये आपके पोर्ट टाइम डायग्राम, ये जो टाइम डायग्राम है टू स्ट्रोक के डायग्राम है. At 4 your exhaust port is being opened, at 5 your inlet port is opened, 6 inlet port is being closed, at 1 your exhaust port is being closed. So these are the timings, these are ordinary terms. In fact, ये आपके जो है वो पोर्ट टाइमिंग डायग्राम को इस तरह से मैंने दिखाया है. अब एक तो स्कैवेंजिंग इस तरह से हो सकती है आपकी, in front side your exhaust port is there, another side your inlet port is there. So from inlet port to exhaust it is just like cross scavenging. It is just like cross scavenging. एक ये loop scavenging है. In this case, both the ports are on the same side. This direction on which it is entering, then going back, and as compared to that one, as compared to the first one, this is advantageous. इसका लंबा पाथ हो गया है, काफी लंबा पाथ हो गया है. So fresh mixture निकलने के chances इसमें काफी कम हो गए as compared to that one. एक जो अपन एनर्जी दे रहे हैं, व्हीकल को जो एनर्जी दे रहे हैं, उसका एनर्जी बैलेंस अगर देखें अपन, यूजफुल आउटपुट करीब 32-30% अपन कहते हैं, बाकी सारे लॉसेज हो रहे हैं आपके, कूलिंग में भी जा रहा है, एग्जॉस्ट में भी जा रहा है, फ्रिक्शन में भी जा रहा है. इट इज ए बैलेंस. समटाइम्स वी आर सेइंग हीट बैलेंस आल्सो. इट इज हीट बैलेंस ऑफ द इंजन. अपन गाड़ी पे जो है हीट बैलेंस तैयार भी करते हैं, है ना, एक इंजन पे आप लैब में तैयार भी करवाते हैं हीट बैलेंस. सो सब में कितनी कितनी एनर्जी जा रही है कैलकुलेट करने के लिए वी आर प्रिपेयरिंग द हीट बैलेंस. थोड़ा थोड़ा मैं इनके बारे में बताऊंगा आपको. थ्रू वीडियो I'll be explaining. Useful power output. First of all, that 30% efficiency which we are saying, useful power output, how it is getting transferred. What is being shown here? Useful power output. That we say around 30% useful power output. How it is being getting transferred? It is transferred either to rear wheels or to front wheels, depending upon front wheel drive or rear wheel drive. If it is rear wheel drive, from the flywheel we are getting the energy. First of all, who receives this energy? Clutch. Clutch is receiving the energy. From clutch to gearbox, then finally differential to the wheels it is going. What is the purpose of gearbox? To vary the speed. We can vary with the accelerator, no? Variation of torque variation we are doing. And power of the engine, same. Whatever engine has been developed, power, we can't live with that one. Power is 2 pi nt. Your engine RPM multiplied by torque which has been developed inside the cylinder. That is power, brake power 2 pi nt which has been developed, and that power we are transferring to the rear wheels. Maybe gearbox, maybe clutch, whatever it may be, it can't change the power. There may be some frictional losses, that is something separate thing, but power won't change. Only variation which we'll be doing, we'll be playing with N and T. With the help of gearbox, we'll be playing with N and T. Power is same, N if we are increasing, your T will go down. If N we are decreasing, your T will go up. So the game which we are playing with the help of gearbox, variation of N and T. Sometimes I'll be coming to that point. What is the meaning of power and what is the meaning of torque? And गाड़ी जब परचेज करते हैं ना, तो मैन्युफैक्चरर उस पे लिखता है कि मेरी गाड़ी का पावर इस पर्टिकुलर आरपीएम पे मैक्सिमम है, मेरी गाड़ी का टॉर्क जो है इस पर्टिकुलर आरपीएम पे मैक्सिमम. दोनों आरपीएम सेम नहीं है. जिस पे टॉर्क मैक्सिमम होता है उस पे पावर मैक्सिमम नहीं होती है, जिस पे पावर मैक्सिमम होती है उस पे टॉर्क मैक्सिमम नहीं होता है. बट एन एंड टी मल्टीप्लिकेशन विच इज देयर, इट इज ऑलवेज सेम फ्रॉम इंजन साइड विच इज कमिंग. तो इस चीज को भी अपन आगे देखेंगे. तो ये करीब 30% अपन इस तरह से ट्रांसफर कर रहे हैं. फिर कूलिंग वाला देखें, कूलिंग में किस तरह से कर रहे हैं. कूलिंग में किस तरह से हीट जो रिजेक्ट हो रही है.
This section examines the cooling system. Combustion of the air fuel mixture in the cylinders generates heat which reduces the high pressure to force the piston down the power stroke. Not all of this heat can be converted into useful work on the piston, and it must be removed to prevent seizure of moving parts. This is the role of the cooling system. Most engines are liquid cooled. A liquid cooling system uses coolant, a fluid that contains special chemicals mixed with water. Coolant flows through passages in the engine and through a radiator. The radiator accepts hot coolant from the engine and lowers its temperature. Air flowing around and through the radiator takes heat from the coolant. The lower temperature coolant is returned to the engine through a pump. Air cooling is common on smaller internal combustion engines. Some engines use cooling fins. The design makes the exposed surface area as large as possible, which allows more heat energy to radiate away and be carried off in convection currents in the air. Some engines also use a fan to direct air over the fins.
Yes, what is coolant? What is coolant? Medium for cooling. Earlier we were having water only. एंड काफी बार देखते थे अपन जो गाड़ियों के ड्राइवर है ना, रोड जो हाईवे पे चलते थे तो कुछ ढाबे वगैरह ढूंढते थे, ढाबे पे रुके, कुछ पानी का डब्बा भर के लाते थे, उसमें डालते थे. These days this problem has gone. What change has been done? Coolant is certainly it's a medium which is taking heat from engine, it is rejecting into the atmosphere. Yes. What change has come now in the coolant? It is not ordinary water. First of all, it is not ordinary water. What it is? What we are mixing into that one?
Alcohol.
Not alcohol, glycol. It is glycol plus water. It's around 50% glycol, 50% water. And the advantage of glycol is it changes its freezing as well as boiling temperature. If 50% glycol in water we are having, freezing temperature of water goes down to minus 38 degrees Celsius. And boiling temperature becomes somewhere around 160 degrees Celsius. So suppose one car we are using here and same car we have gone to Ladakh, where temperatures are very low. If only water we are having just like a coolant, in that temperature, where temperature -3, -4, -5, so water will freeze. The water will freeze, your tubes, everything will burst into that one. So the additives which we are having, particularly glycol which we are having, if you have mixed into this one, freezing temperature of water will be going down to minus 38 degrees Celsius. Up to minus 38 degrees Celsius, it won't freeze. So that's the biggest advantage. Another one, boiling of the water is taking place. If atmospheric pressure is there, boiling is at 100 degrees Celsius. If you have mixed glycol into that one, 50% glycol, your boiling temperature has gone up 160 degrees Celsius. So if boiling is not there, the vapor losses which earlier we were having, those vapor losses are not there. Even some vapor losses are there, those are being trapped back and it is coming into the reservoir which we are having. So the biggest advantage which we are having, the coolants which we are, these are non-consumable, as well as they can operate at the extreme conditions of the weather. Second one, कुछ कलर भी मिलाया हुआ होता है इसमें, कुछ ग्रीन कलर जो है. Yes, some dyes we are mixing. Identification. Suppose you have parked your vehicle and if some leakage is going on in the radiator, so driver जब भी वहां से start करेगा तो उसको पता चल जाएगा ना नीचे कुछ green जो है गिरा हुआ है. It means your coolant is leaking from that one. So it's dye. Those are mixed with for the purpose of identification. फिर आपका जो और भी उसके अंदर एंटी कोरोजन और काफी एडिटिव्स जो है इसमें मिक्स किए होते हैं, जिससे लाइक पार्डन.
So what is the effect of pressure?
If pressure is increasing, your boiling temperature will increase. It will go up. It's a function of everywhere. Pressure is affecting the boiling temperature. But if pressure is increased into the system, chances of leakage will become very high. The materials which we will be using for the purpose of construction, that has to be more stronger for sustaining that. We never want any system to operate below atmospheric pressure or above atmospheric pressure. If it is below atmospheric pressure, leakage of atmospheric air into the system. If it is above atmospheric pressure, leakage from the system to surrounding. So always, whatever the system we are, not only engines I am saying, wherever we are operating the system, we want up to the possible extent that system should be operated at atmospheric condition. So the chances of leakage should be avoided. So this is lost through this cooling system. And you can recognize from here that intensely heat we are rejecting the surrounding. Very costly petrol we have purchased, we have paid for that one, and unwanted heat, unwanted method we have applied for rejecting that heat, useful heat which we have obtained from the petrol, we are rejecting to the surrounding. So these days efforts are being done if without cooling engine can be operated. Some of the engines are coming, particularly diesel engines, adiabatic diesel engines are being tried, where this heat transfer is becoming more or less zero. No radiator, nothing is there for utilizing whole heat for the purpose of useful power output. But in that case, metals which we are using, those metals should be very special, particularly at higher temperature. Expansion of those metals as well as distortion of those metals can be avoided. So if those type of metals can be available, this can be without cooling even. And even if air cooling and air cooled and water cooled engine, if you are comparing, your air cooled engine is better because heat losses in that case will be lesser as compared to water cooled engines. Another video I will be showing you about the lubrication system. Friction वाला जो part है, आपके friction में जो energy जा रही है.
This section examines the lubrication system. All moving parts of an engine require lubrication. That is, the application of oil to moving parts to reduce friction between them. A lubrication system is feeding oil through the engine. A typical lubrication system consists of an oil sump, an oil pump, and oil galleries. The oil is stored in the sump, bolted to the bottom of the engine block. Oil is drawn from the sump by an oil pump. Oil galleries are small passages in the cylinder block that direct oil to the moving parts. Oil that is being pumped to the crankshaft main bearings travels through oil ways to the connecting rods. Oil may also be splashed from the connecting rods onto the cylinder walls. A filter is usually provided to remove particles of dirt from the oil, and the circulation of the oil assists with the cooling of the internal parts.
So lubricating oil basically between two metallic components, it is making a layer, it is reducing metal to metal contact, and losses are being decreased. Now question of power and torque is coming. I said difference between power and torque. Suppose you are having a motorbike and some loose sand is there. You want to overcome loose sand or some mud is there, and that you want to overcome. उसके ऊपर से जाना है आपको, लूज सैंड के ऊपर से जाना है. Torque will decide that will be able to overcome that resistance or not. हम उस पे से निकल पाएंगे या नहीं निकल पाएंगे. And power is deciding that how quickly we'll be able to overcome that resistance, how rapidly we'll be able to move across that resistance. So difference between torque and power is, torque is basically will be able to overcome that resistance or not. Time is not coming into picture. In the case of time, in the case of torque, time is not the parameter. In fact, when we are saying power, power is governed by time, with respect to time that we are moving, and how quickly we'll be able to overcome that resistance, that is decided by the power. So ये दोनों चीजें मैंने आपको यहाँ बताई है. टॉर्क के अंदर कि निकल पाएंगे या नहीं निकल पाएंगे. पावर ये बता रही है कि जो कितना क्विकली. So power from the engine which is coming out, it is constant. It is varied by the fuel supply. Accelerator is, when it is being changed, power will be changed. If accelerator is constant, power which is being produced by the engine, it is constant. After that, when at constant throttle, variation of torque, yes, we are able to overcome the resistance or not, that is decided by the gearbox. That variation in the torque from engine side, torque and power which is going, it is constant at one particular throttle position, but after that one, the game which is being played for variation of torque, that is by the gearbox. ये कर्व मैं आपको दिखा रहा हूं. There are two separate curves. One curve is for power, another one is torque. देखिए आप दोनों कर्व, ये ऊपर वाले मेरे कर्व बताइए पावर का कर्व, ये नीचे वाला टॉर्क का कर्व है. टॉर्क इज मैक्सिमम एट व्हाट आरपीएम? Torque is maximum at what RPM? X-axis is having RPM. Yes, in bottommost you see this one. Roughly 4,800 RPM. Your torque is maximum, and power is maximum at 6,500 RPM. Both are not at the same RPM. The reason for this one is, one term we are defining in the case of engines. Earlier we said volumetric efficiency. New term I am defining, it is termed as unit air charge. Unit air charge. Meaning of unit air charge is that in suction stroke, in one particular stroke or in one particular cycle, how much amount of air has been sucked into the cylinder. It is in grams per cycle. Unit air charge is grams per cycle. Vehicle is moving, your engine is moving. In a particular cycle, how many grams of air has been sucked into the cylinder in that particular cycle? Are you getting this one? Unit air charge is amount of air which has been sucked into the cylinder in a cycle. जब 4 स्ट्रोक कंप्लीट होते हैं, एक साइकिल कंप्लीट होती है, उसमें एक सेक्शन स्ट्रोक होता है, उस दौरान कितने ग्राम जो है उसमें पर साइकिल उसमें एंटर हो गया है, इट इज यूनिट एयर चार्ज. अब इंजन अगर 2000 आरपीएम पे चल रहा है, इंजन अगर 2000 आरपीएम पे चल रहा है, एंड unit air charge is 10 grams per cycle stores. If engine is being operated at 2000 rpm, how many suction strokes will be there?
5
सक्शन स्ट्रोक्स. साइकिल कितनी हो गई आपकी? 2000 आरपीएम पे साइकिल कितनी हो गई? हाफ ऑफ दैट वन, हाफ 1000. If 1000 cycles are there, 1000 suction strokes will be there. Number of cycles equal to the number of suction, number of exhaust, number of compression. एक साइकिल में एक ही बार ये चीजें आती है ना, एक बार सक्शन होता है, एक बार कंप्रेशन होता है, एक बार. So if it is operated at 2000 rpm, number of cycles will be 1000. Are you agree? If 1000 cycles are there, number of suction strokes will be 1000. So unit air charge in one cycle, I am saying we are taking 10 grams of mixture per cycle. So in 1000 cycles, how many grams will be able to take? 10 multiplied by 1000. Yes, 10 multiplied by 1000. 10 किलोग्राम अपन ने जो है 1 मिनट में ले लिया. ठीक है? Okay. Now in place of 2000 rpm, suppose it has become 3000 rpm. If rpm is 3000, inside the cylinder vacuum which is being created, it will be more as compared to 2000 because piston is moving rapidly. The air which is entering from that side, even grams per cycle, it will also starts to increase. जो 10 ग्राम मिल रहा था 2000 पे अपने को एक साइकिल में, when it has become 3000 rpm, in place of 10 grams per cycle, it may become some 12.5 grams. It will increase because pressure difference is increasing inside the cylinder and outside there is atmospheric pressure. So per cycle जैसी स्पीड आपने 3000 की है, so per cycle जो यूनिट एयर चार्ज आ रहा था, that has gone up. In per cycle, if it is increasing, it is increasing the torque. Torque doesn't have time unit. It is not in terms of minutes. It is per cycle it is increasing, means torque developed by the engine is increasing. And number of cycles are now 3000 rpm. I am saying number of cycles will be 1500 per minute. The amount which will be entering, it will be 12.5 multiplied by 1500. तो आपका पर मिनट भी बढ़ गया, आपका पर साइकिल भी बढ़ा, जो टॉर्क बढ़ा रहा है, और पर मिनट जो बढ़ा है वो पावर बढ़ा रहा है आपका. Because power is dependent upon the time and torque depends upon without time, per cycle basis पे जो है डिपेंड कर रहा है. तो जैसे जैसे आप आरपीएम बढ़ाते जा रहे हैं, वैसे वैसे आपका यूनिट एयर चार्ज भी बढ़ रहा है और आपकी पर मिनट जो आ रहा था वो भी बढ़ रहा है, तो योर पावर इज ऑल्सो इंक्रीजिंग. Suppose RPM becomes 4000. When RPM is becoming much more, the air which is entering into the cylinder, it will be facing lot of friction also. Intermolecular friction, as well as because it is moving through the duct, that friction is increasing. One situation at one particular RPM may come when unit air starts to decrease. जो 12.5 था वो हो सकता है वापस जो है 9 या 8 या 11.5 हो गया हो, because that friction starts to dominate. But number of cycles now it has become 2000. Even it has become say 10 and number of cycles are 2000 as compared to even when it was having 12.5, as compared to that it has gone down, per cycle it has gone down. But per minute if I am multiplying, per minute it is still increasing. Are you getting this one? कि number of RPM जैसे बढ़ रहे हैं तो number of cycles बढ़ रही है, पर यूनिट एयर चार्ज एक पर्टिकुलर स्पीड के बाद कम होना शुरू हो जाता है ड्यू टू फ्रिक्शन. But because number of cycles, total amount of air which is entering into the cylinder per minute, that will be number of cycles multiplied by unit air charge. That multiplication still it is increasing, and that is increasing the power. Your unit air charge has started to decrease, means torque has started to decrease, but per minute the amount of air which is entering, that is continuously increasing, that is increasing the power. Are you getting this one? One particular RPM may come when unit air charge has become so less and RPM has gone quite high, your multiplication also starts to go down. Multiplication of unit air charge and number of cycles which is happening per minute, that multiplication starts to go down, then power will starts to go down. I think it should be clear. Yes. जो ये डिक्रीज हुआ है पावर के अंदर, ये जो पावर में डिक्रीज हुआ है, ये पावर में जो डिक्रीज हो रहा है ऊपर वाले में, ये तब हो रहा है जब उनका मल्टीप्लिकेशन भी कम होना शुरू हो गया, और ये आपका कम होना तब शुरू हो गया जब पर साइकिल में जहाँ पे फ्रिक्शन ने डोमिनेट करना शुरू किया, then it has started. So every manufacturer is specifying that in mine vehicle the torque is maximum at 4800 rpm, mine power is maximum at this one. I think it should be clear. अब ये जो है, ये जो यहाँ पे उसने मैक्सिमम तो दे दी, लेकिन कम भी तो पावर है उसके इंजन की, कम भी तो है उसके इंजन की पावर, यहाँ पे कम है. वो सिर्फ जो क्या डिफाइन करता है आपका मैक्सिमम विद रेस्पेक्ट टू टाइम. अनदर पावर इफ आई एम डिफाइनिंग हियर इट इज वाज 200, 175 कब है उसकी, जब इंजन के आरपीएम 5500 है. इससे और 150 तब है जबकि इंजन के आरपीएम 5000 है. सो पावर इज नॉट कांस्टेंट. पावर ऑफ एनी इंजन इज नॉट कांस्टेंट, इट्स ए फंक्शन ऑफ आरपीएम. मैन्युफैक्चरर सिर्फ एक स्पेसिफाई करता है, दैट इज मैक्सिमम. अदरवाइज इट्स ए फंक्शन ऑफ आरपीएम. पावर इज कंटिन्यूसली changing depending upon your throttle position, depending upon engine rpm, your power will be something different and that power will be transferred on the rear wheel. Similarly the torque is not constant. Torque जो है यहाँ पे जो भी torque है ये सारा constant नहीं है. it's a one particular rpm, it is maximum, otherwise it is going down and up. अब ये जो torque है, इंजन का जो torque है, अगर सीधा अपन rear wheel को transfer करते हैं, so how much force will be available to move the vehicle in forward direction? The same torque we are transferring, your radius of the vehicle, radius of the wheel multiplied by the force, that is the torque in fact that is getting transferred to the rear wheels. So R of the wheel is constant. The force which is moving vehicle in forward direction, that is termed as tractive effort. That tractive effort is moving vehicle in forward direction. So इस particular torque पे जो भी tractive effort मिलेगा, किसी भी RPM पे ऑपरेट कर रहे हैं अपन, इस particular RPM पे ऑपरेट कर रहे हैं, tractive effort is constant. Now vehicle is moving in forward direction and we'll have to climb some height say, or rolling resistance which we are having, if it is there, आपको climb करना है, या you are moving at a higher speed, then your air resistance is also dominating. It is frontal area multiplied by velocity square. Three resistances are there. One is rolling resistance, another one is your air resistance, third one is gradient resistance, and that is also in terms of force, that is opposing that tractive effort by which vehicle is moving in forward direction. If your tractive effort is less and your resistances are more, then they won't be permitting vehicle to move in forward direction. अब आपका इंजन तो ट्रैक्टिव एफर्ट बढ़ा नहीं सकता, इंजन ने तो उस पर्टिकुलर टॉर्क पे जो भी ट्रैक्टिव एफर्ट देना था वो दे दिया, एंड नाउ द रेजिस्टेंसेस व्हिच आर देयर इन टर्म्स ऑफ एयर रेजिस्टेंस और ग्रेडियंट और रोलिंग, they are opposing to this one. We don't have any method to increase the tractive effort. Now what method we will be having so that we can climb with, yes, then gearbox is coming to picture. Gearbox क्या करता है, ये जो लाइन है आपकी, इसको बॉडीली ऊपर मूव कर देता है, नॉट इंजन लाइन, इट इज इनसाइड द इंजन. आपका इंजन के बाद जो टॉर्क मिल गया उसको बॉडीली ऊपर की तरफ मूव कर देता है. सो ट्रैक्टिव एफर्ट इज इंक्रीजिंग. द टॉर्क व्हिच इज कमिंग आउट फ्रॉम द इंजन इट रिमेन्स सेम, बट the gearbox is changing that torque so that we'll be able to overcome that resistance. ये जो कल हॉर्स पावर की बात बता रहा था मैं आपको, है ना, 1 हॉर्स पावर इज 33,000 LB फीट पर मिनट. जो वाट ने जो मेजर किया था, वाट ने मेजर किया था एक घोड़ा जो काम करता है, उसने 1 मिनट में घोड़ा एक जो है आटा चक्की का मान लो काम कर रहा था, and the diameter which it was having and the radius which it was having, it was 12 meters, and in 1 minute he was taking 144 rounds. तो उसने डिस्टेंस कवर कैलकुलेट कर ली उसे पाई डी से या 2 पाई आर से डिस्टेंस कैलकुलेट कर ली. 1 minute टाइम ही वाज हैविंग एंड ही हैज अज्यूम्ड दैट 1 horse is having force equal to 180 lb. So 180 lb multiplied by 2 pi r, that he has got 33,000 foot lb per minute. In 1 minute he has calculated. आर को उसने मिनट में कैलकुलेट, इसको एक हॉर्स पावर जो है उसने डिफाइन किया. ये जो पीएस पावर और मैं कल आप लोगों को बता रहा था, पीएस इज मोर और लेस हॉर्स पावर, इट इज 0.986 ऑफ द हॉर्स पावर, जो 735 या 735.6 वाट को जो कन्वर्जन है, दैट इज इन टर्म्स ऑफ पीएस एंड द हॉर्स पावर व्हिच वी आर यूजिंग. और दिन भी इसको यूज करते हैं अपन. ये वो 746 वाट 735 वाट में बता रहा था, 745 वाट, अलग अलग कंट्रीज जो काम में लेते हैं हॉर्स पावर को कन्वर्ट करने के लिए, मल्टीप्लाइंग फैक्टर जो काम में ले रहे हैं. ये अगर स्पेसिफिकेशंस की बात करें इंजन के, कुछ टर्म्स तो अपने डिफाइन कर दी. देखो आप, SOHC वी सेट, SOHC फर्स्ट ऑफ ऑल इंजन टाइप मॉडल 1.4 लीटर, 1.4 लीटर इज स्वेप्ट वॉल्यूम, swept volume of all the cylinders which are there, and SOHC we said single overhead cam for that purpose. Displacement वो जो 1.4 लीटर को सीसी में दिया हुआ है 1405, it is centimeter cube. Then power we said 60 PS at one particular RPM. One particular RPM is also being specified. that at this particular RPM this much power is developed, and then torque when he has defined 105 Newton meter for this. And normally as a thumb rule, the RPM at which torque is maximum, power is maximum at double of that RPM. If torque is maximum 2500, more or less power will be developed at double of that one, 5000 RPM. It will be double that one. Then valve mechanism, we said bore, stroke, compression ratio, number of cylinders, cylinder configuration in line. All the cylinders are in a line. Valves per cylinder 2, they are saying fuel type, fuel system. This is the power and torque. Again, measurement of torque, and torque is needed for calculating the brake power 2 pi nt. और जो ब्रेक मीन इफेक्टिव प्रेशर की बात में फर्स्ट ये आइए, आप इस कर्व पे अगर देखते हैं अपन, दिस इज द एरिया ऑफ द डायग्राम व्हिच वी सेड. दिस टर्म, द इंपॉर्टेंट टर्म इज दिस वन, दैट इज टर्म एज मीन इफेक्टिव प्रेशर. हाउ वी आर डिफाइनिंग मीन इफेक्टिव प्रेशर? व्हाट वी आर डूइंग? We are, yes, this pressure volume diagram which we are having, area of this one, if you integrate this one, area of this one equal to this, if you draw a rectangle equal to this area having same base, that is equal to the swept volume, yes, and the TDC to BDC, that volume on the x-axis, on y-axis equal to this area we are plotting a rectangle. This height of this rectangle is mean effective pressure. Is it clear? अगर अपन PV डायग्राम का एरिया जो है उसको एक रेक्टेंगल में कन्वर्ट कर ले, your x-axis is same, that is swept volume, and now y-axis, the height of this rectangle is, we are assuming that constantly there is a pressure which is working on the surface of the piston throughout the cycle. That term is mean effective pressure. This mean effective pressure multiplied by swept volume, it is work done. इसमें जो वर्क डन मिला है अपने को वो वर्क डन हो गया. सो योर पावर विल बी, इंडिकेटेड पावर विल बी मीन इफेक्टिव प्रेशर मल्टीप्लाइड बाय स्वेप्ट वॉल्यूम. एंड ये कितनी साइकिल में मिला है अपने को पावर? एक साइकिल में. एंड हाउ मेनी रिवोल्यूशंस ऑफ द क्रैंकशाफ्ट व्हेन वी हैव गॉट दिस पावर? 2. इफ इट इज 4 स्ट्रोक इंजन, 2 रिवोल्यूशंस. इन 2 रिवोल्यूशंस दिस मच वर्क आउटपुट वी आर गेटिंग. सो your indicated power output will be mean effective pressure, this height multiplied by Vs. It is in a one cycle, and number of cycles in a minute will be n by 2. RPM अगर n है, so number of cycles will be n by 2. So per minute output will be having mean effective pressure multiplied by swept volume multiplied by n by 2 if it is 4 stroke engine. Yes, if it is 2 stroke engine, number of cycles and number of revolutions will be same. Mean effective pressure, swept volume, this axis multiplied by n, that will be giving you the power output. But if you are measuring this brake power, here it hardly matters if it is a 2-stroke engine or 4-stroke engine. Your brake power will be always equal to 2 pi nt. We don't know what prime mover is operating this flywheel. It may be electrical motor, it may be electrical generator, it may be your engine, 2-stroke engine, 4-stroke engine. Just we are measuring the RPM of the crankshaft and force which is being applied through dynamometer on the surface of the flywheel. So here it is 2 pi nt, not n by 2. But if it is indicated power, because it is inside the cylinder, when 2 cycles are completed, 1 cycle we are getting where mean effective pressure is being obtained. Obtaining mean effective pressure is a tough task, because for that purpose we'll have to have PV diagram. PV diagram will be having only if you are having P theta diagram. So जो इंडिकेटेड पावर मेजर करनी है वो ये मेथड जो है स्लाइटली कॉम्प्लिकेटेड, इंडस्ट्रीज में ये मेथड काम में नहीं आता है. लेबोरेटरी पर्पसेस के लिए और जो भी अपन काम करते हैं उसके लिए है. दे आर हैविंग सेपरेट मेथड, जो मोस्ट टेस्ट है या विलेंस लाइन मेथड है या मोटरिंग टेस्ट है. दोज आर द मेथड्स बाय व्हिच वी आर मेजरिंग द इंडिकेटेड पावर. तो बताओ कितनी लेट हो गई है? अच्छा, तो अपन ब्रेक कर लेते हैं at 2 exactly. Till that time he'll be reaching. So yes,
प्रैक्टिकली हम कैसे मीन इफेक्टिव प्रेशर जो है कैलकुलेट कर सकते हैं?
प्रैक्टिकली मीन इफेक्टिव प्रेशर, एक तो ये तरीका मैं बता ही रहा हूँ आपको. मीन इफेक्टिव प्रेशर अपने पीवी डायग्राम बनाए, उसे मीन इफेक्टिव प्रेशर जो है ले. दूसरा अपन ब्रेक पावर निकालें, आप मोस्ट टेस्ट से इंडिकेटेड पावर निकालें और इंडिकेटेड पावर और मैकेनिकल एफिशिएंसी निकाल के उससे जो है अपन मीन इफेक्टिव प्रेशर कैलकुलेट करें. जब इंडिकेटेड पावर निकल जाएगी, आपका स्वेप्ट वॉल्यूम आपको पता है, एन आपको पता है, यू कैन फाइंड आउट मीन इफेक्टिव प्रेशर. But for that purpose, either we'll have to have most tests, either we'll have to have Williams line method, then only we'll be able to calculate. It is not measurement, it is calculation in fact. So shall we close?
Yes.
Any question from other centers? TTC जोधपुर, TTC जोधपुर मेरा साहब कहाँ गए? TTC जोधपुर दो
Good afternoon, sir.
हाँ गुड आफ्टरनून.
Sir, is there any other method to find out the? I'm calling from IIT Badal. Sir, good afternoon. I'm calling from IIT Badal.
Please continue.
Is there any another method to find the mean effective pressure in a distance similar arrangement other than the boost test?
Yes, we are having most of them. We are single system. We are having Williams line method. Even we are having motoring test also. With the engine, we are having generator. With generator, so with that, we are fixed losses are there. We are getting indicated power, and with the indicated power, we are able to calculate. Motoring test. Motoring test. कोई और पूछ रहे?
Hello.
Yes, yes.
Sir, your voice is not audible. Please make us to understand after this session. The next session.
Which center it is?
The voice is not audible, sir. Please repeat it.
Which center? For this
I'm calling from IIT Badal, Ropar.
Yes, I am saying for obtaining this mean effective pressure, either we'll have to have P3 diagram. If you are not having P3 diagram, then you'll have to do most tests. If you are not doing most tests, you'll have to do Williams line method test for a single cylinder engine. If it is not there, then we'll be going for motoring test. And with the help of that motoring test, we'll be finding out friction losses, and then brake power we are calculating. We are adding friction losses and brake power, then we are getting indicated power, and with the help of indicated power, we are getting mean effective pressure.
Thank you, sir.
Okay. Thank you. So we'll be continuing at 2 o'clock. आप दामी साहब please convey. आप भी गए? अच्छा. Okay.
Thank you, Professor Poonia. So there is a request to all the centers. Please wait for 2-3 minutes. Our next speaker, Professor Ramesh, is here. So he'll be coming to the studio in any moment. So in the meantime, if anybody has any other question from the centers or from the participants in the studio, you can please ask the questions.
Till Dr. Ramesh comes, any query, any question, whatever I have covered, I'll be trying to answer your queries. हाँ बताओ. बताओ यार, क्वेश्चन होने चाहिए ना काफी. नहीं तो पढ़ाने का फायदा क्या होगा? बताओ, जो क्वेश्चंस नहीं होंगे तो.
सर हम इंजन की पावर बढ़ाना चाहते हैं, क्या करेंगे?
इंजन की पावर बढ़ाना चाहते हैं, बताओ आप लोग ही बताओ क्या क्या कर सकते हैं. पावर बढ़ाने के लिए सबसे इंपॉर्टेंट चीज क्या है? आदमी की पावर बढ़ाने के लिए सबसे इंपॉर्टेंट चीज खाना है. इंजन का खाना क्या है? चार्ज. यस, चार्ज इज इंजन खाना. Charge means for diesel engine it is air. If it is petrol engine, it is air plus fuel vapors. Those has to be increased. In a given time, this volumetric efficiency part has to be increased. The amount of air or air plus fuel which is entering into the cylinder, that has to be increased. और power के लिए क्या आ रहा है? और factor क्या आ रहे हैं आपके? Power is 2 pi nt. Yes, what another thing is coming? Your n is coming to picture. If you are increasing the power, your n has to be gone up. But If you are increasing N in diesel engine, we are seeing serious problem about knocking is coming. In the case of petrol engine, even RPM above a certain limit, if you are increasing, it's a reciprocating mechanism. Unbalanced forces are there. As RPM is increasing, your friction losses also significantly increases. So above a certain limit, we can't increase the RPM also. फिर आप ये टर्बो चार्जिंग, सुपर चार्जिंग सारे मेथड्स हैं बेसिकली फॉर इंक्रीजिंग द पावर आउटपुट ऑफ द इंजन. कंप्रेशन रेशियो इफ यू आर इंक्रीजिंग, योर पावर विल गो अप, बट सेम टाइम आपका पेट्रोल इंजन है तो आपकी नोकिंग बढ़ जाएगी एट हायर कंप्रेशन रेशियोज. इन द केस ऑफ डीजल इंजन, इफ वेरी हाई कंप्रेशन रेशियोज वी आर कीपिंग, सपोज 15-16 से ज्यादा अगर रखें अपन, क्या दिक्कत आ सकती है? If compression ratio is quite high, what problems we may face? Higher the compression ratio, first of all, pressures will be very high inside the cylinder. Yes, sustaining that pressure, the metals which we'll be using or the manufacturing cost which we'll be having, that will be quite high. Another one, heavy weight. Yes, heavy weight. Another one, starting of engine becomes difficult. आपको स्टार्ट करना है एयर को, सबसे पहले तो उस कंप्रेशन रेशियो तो कंप्रेस करना पड़ेगा ना, देन ओनली विल बी एबल टू स्टार्ट द इंजन. So higher the compression ratio, the battery power which is needed for the purpose of starting, for the purpose of cranking, or manually if you are doing, that becomes very difficult. If compression ratios are higher, leakage across the piston rings, because in the combustion chamber pressures will be quite high, leakage across the piston rings, that will also becomes quite high. So losses will be quite high. So at some particular level will be having that compression ratio, where starting is easier, your losses are not up to that mark, your pressures are not so high, so we can manage everything up to that. We are increasing the compression ratio.
The cost of the rotary engines
Wear and tear also increases with higher compression ratios. Okay, wear and tear is suggesting wear and tear will be increasing. First of all, pressures are higher, temperatures are higher. That metallic, the distortion will be much more, wear tear will be quite high, and even at higher temperature, lubrication of engine becomes quite difficult, because lubricating oil starts to burn. It won't be making layer over the surface of that one, and that's the serious problem in the case of two-stroke engines. In two-stroke engines, alternative stroke is a power stroke. Alternative, there is firing, alternative combustion is going on. So lubricating oil which is there, it is unable to make layer because temperatures are higher in the case of two-stroke engine. So biggest challenge in two-stroke engines are its lubrication, its cooling, because alternative stroke is a power stroke, so cooling is difficult. Materials which you are using, that the life of the metal, that will be lesser, and maintenance of that engine, that is becoming very difficult. So that's the major difficulty which we are facing in the case of two-stroke engines.
the rotary engines developed in the past, like petrol engine.
Yes, yes. Yes. So as compared to reciprocating engine, if rotary engines are there, balancing will be easier. Just like gas turbines, no? In the case of gas turbines, morning. Please, sir, please. So in the case of rotary engine, your balancing becomes quite easier as compared to reciprocating engine. So gas turbines are better as compared to reciprocating engines as far as balancing is concerned, your vibrations are concerned. But in that case, another difficulty is their compression ratios are lesser, their efficiencies are poorer as compared to internal combustion engines. So efficiency point of view, your internal combustion engines are better. Smooth running point of view, if you are saying, your gas turbines are better. Where rotary movement is there, balancing will be easier. So if no question is there, I'll be closing this session here, and our next speaker, Professor A. Ramesh, is with us. We are very happy. From Chennai is coming, IT Chennai is coming. Flight was late, but we are lucky that he is available with us. So sir, I'll be requesting, first of all, Professor Dami, I'll be requesting for introducing our guest, and just for 5-10 minutes we'll be continuing, then we'll be breaking for our lunch. Some 10 centers are connected here, sir. Yes. Just then yes. 10 centers are connected. Parts of the country.
Just a minute. I will introduce the next speaker. After that, you can have your queries. Right? So it's a pleasure to welcome Professor A. Ramesh from IIT Chennai. So he is here to discuss and share his expertise and knowledge with the participants from 9 different centers connected through ICT and the participants present here in the ETV studio at this institute. So, sir, we all welcome you here. I'll briefly introduce Professor Ramesh. He is his master's and his PhD is from IIT Chennai. Then from 92 onwards for 4.5 years he was in IIT Delhi. After that he joined IIT Chennai. Right now he is professor and head of internal combustion engine laboratory at IIT Chennai, and he has to his credits many PhDs and many papers in international journals, national journals and international conferences. His areas of interest are alternate fuels, engine emission control, new engine designs, engine modeling for control, engine management systems, and homogeneous charge compression ignition engines and gasoline direct injection systems. So I'm sure that Professor Ramesh's presence here for 2 days and his interaction with the faculty members and technical staff of different colleges will help them to gain knowledge which is not normally available in the books. So I'll now request Professor Ramesh to please say a few words and interact with the participants.
Good morning and good afternoon. Actually, I was supposed to be here at about 11 o'clock, but due to unavoidable reasons, there's a delay in the flight. I'm sorry for that. Basically, as I was told by the director of this institute, Professor Poonia, I should be covering topics which are related to internal combustion engines. That also happens to be my field of interest, so definitely I love to do it. And also interacting with many teachers, not only here, elsewhere also. I was told that there are some 10 centers.
Yes, sir.
10 centers.
Teachers are sitting at faraway places.
Yes, I'm also able to see a few of the centers here. So it's my first experience. First of all, when I entered this, I was actually astonished and shocked. I never thought that I'm going to enter into something like this. And so it's amazing to see the level of technology and how we are able to connect. And I'm sure I'll try to make the best use of this facility so that it really is beneficial to everyone. So basically, we'll be covering topics related to engines. And first of all, I think I should start with two-stroke engines. That was the first topic given to me. So we know that two-stroke engines are slowly going away, but they will not completely vanish. They are going to be in several areas, which we'll see in the afternoon. So it is not.
Excuse me, video quality is not good. We are not receiving in the good video quality. Now it's okay. Now it's okay.
Okay.
So basically, two-stroke engines are here to stay and may not be in two-wheelers, but may be in other sectors and some very small two-wheelers. So we look at two-stroke engines in the beginning. Then we have turbocharging and supercharging, and then we have cylinder pressure measurement and electronic engine management. So I thought here we could make a small change in the order.
Yes,
I thought we can first go to electronic engine management, then go to turbocharging and supercharging, and then finally go to cylinder pressure measurement. So this way I think it would be better. I was just thinking that this would be a better schedule. So in electronic engine management, we'll try to look at the fundamentals behind engine management systems, why we really have engine management systems in spark ignition engines and in diesel engines, and how the modern engine management systems work. I'll just give you an overview because we don't have too much time. So overview, and then we'll look at the future, that is the direct gasoline direct injection systems and the common rail injection systems and so on. And then we'll move on to the turbocharging and supercharging area, where we look at some of the fundamentals of turbocharging and supercharging and some of the modern methods by which these are achieved now, right from the variable geometry turbochargers to turbochargers which do not, the so-called superchargers which are driven by pressure waves and so on. So we look at these kinds of supercharging systems, and then finally go to cylinder pressure measurement. Cylinder pressure measurement is something which is inevitable when we are doing research. Any researcher in engines would definitely try to get cylinder pressure. It is like the ECG of an engine. So it gives a lot of information, and it is very common, but it's not very easily done. So it needs a lot of care to get very good cylinder pressure signals. So we look at this and how we can process cylinder pressures to signals, and what information we can derive out of cylinder pressure and so on. So that would complete the 4 topics which I would like to share with you. So and I think it will be a very interactive session.
Yes, sir. They are having idea about combustion, the combustion in CI engine, combustion in SI engines, basic idea of the engine, cooling system, lubrication system. Those contents have been covered in yesterday and today I have covered. So basic ideas they are having. Even P3 diagram they are knowing. Then pressure measurement part will be coming.
So I think we can just take off from that level. And then
and it is in interactive mode, two ways. Sir. They'll be asking in between tuitions, will be asked from different centers also. These centers which are there, they are through YouTube, sir. And these are through video conferencing. Yes. So at different places we have put our video conferencing equipment, 5 places. And in YouTube, it is live also, sir, on YouTube. Any corner of the country at the world, you will be visible now, sir. Live, you will be visible.
Okay.
Yes. And in YouTube, they'll be interacting, sir. Through YouTube, they'll be interacting now.
Okay. So it's very interesting. In fact, this is the first time I'm experiencing this. I've heard of it, but I've never experienced it.
But it will be a wonderful opportunity to teach us, sir. Professor from IT Chennai coming in this area, particularly in a specialized area. So it will be a wonderful opportunity for teachers also of this region. And we'll be recording these lectures, so of course in future we can utilize these videos, sir.
Thank you very much. I think we'll have more time to interact in the afternoon. Thank you.
Right, thank you everybody. So now I think we can break now. At one center there were a few